Cert Higher Level 2015 Paper 2 Question 7 is a trigonometry question. A flat machine part consists of two circular ends attached to a plate as shown. The sides of the plate HK and PQ are tangential to each circle. So they're tangents. The larger circle has center A and radius 4r, and that's in centimeters, and the smaller circle has center B and radius r centimeters. The length of HK is 8r and AB is 20 root 73. Find r, the radius of the smaller circle, and they give you a hint in this question. Draw BT parallel to KH, where T is an element of AH. So what they wanted you to do was leave r and come this way and draw a line parallel to HK and call this T. Now this is not drawn to scale because this is going to be r because it's parallel to the 8r, and this one will be 3r. So we now have an 8r here. This has to be 8r as well. We have the 3r that I put on, and we have this 20 root 73. And this is going to be a right angle triangle here. So both of these are right angles. Where the T is, I'll just move the T, put it here. So this is a right angle. So we have a right angle triangle where the hypotenuse is 20 root 73. So we can say 3r to be squared plus 8r to be squared is equal to 20 root 73 to be squared. 3r squared is 9r squared plus 64r squared. That's going to give me 73. Okay, we have a 73 on both sides. 73r squared is equal to, that's 20 squared by root 73 squared is 400 by 73. So I'll leave it in that form because I can see now that I'm going to be able to divide by 73. So r squared is equal to 400. So r must be equal to 20. And that would be centimeters. Now, part B, find the area of the quadrilateral ABKH. What are we dealing with here? ABKH. I left my B out to the center of the circle. So ABKH. Okay, so we've got this rectangle up here, which is 8r times r, which is 8r squared, and r is 20, so that's 8 by 20 squared. A400 are 3200 cm squared. And then we have the right angle triangle, and half the base by the height. We can take the height as 3r and the base is 8r, so I'll just bring that down. 3200 cm squared plus half the base by the height. We had 8r and 3r. So half 820s 160, 320s 60. So we have 30 160s, which is 4800 cm squared plus 3200 cm squared is going to give me an even 8000 centimeters squared. Part C, find the angle HAP in degrees, correct the one decimal place. Let's look at our diagram. HAP, this angle here. So I have this angle inside the right angle triangle, and they're both tangents, so these lines are equal. HA is equal to HP. So if I can get that angle there, I can just double it. So what have I got? I've got my right angle triangle. I have that side. So the tan of this angle, if I just do this right angle triangle upside down like this, we're looking for this angle here. We have 160, 8r over there, and we have 60 here. O over A. So the tan of this angle, let's call it the tan of x is equal to O over A, 160 over 60. So x would be the inverse tan of that. And we type that into my calculator. That's going to give me 69.44 degrees. So I just need to double it. So I've got 69.44 degrees by 2. It's going to give me 138.9 to one decimal place, 138.9 degrees. So part 2, find the area of the machine part, so the total machine part. So what are we looking at here? We have, well, these two sections, this side over here, the one we've already got the area of the quadrilateral, that's equal to the one over the other side. So it's twice the answer from the 8,000, twice of the 8,000. So we can do that in a minute. So what am I left with? I'm left with an arc. I'm left with a portion of a circle. So I need to get these angles. So let me just draw out these small arcs of circles. So on the right hand side, I have an arc of a circle that looks like this. And on the left hand side, you can see here, I've got the arc and it's kind of going in the opposite direction. The two radiuses are like this. And these are obviously just sketches. So my radius, just to check, it was 4r, wasn't it, for the big one? 4r and r for the small one. Okay, and a little bit of geometry knowledge here. So I have a radius of 20 on this one, 80 on this one. I've worked this angle out here in the previous part to be 138.9. Now you can see that that angle and that angle are going to be the same. And so I can get the area here, pi by 20 squared by the fraction of the circle. So 138.9 over 360 will give me the area of that one. And over this side, I need to get this angle, which is 360. What's 360 minus 138.9? That's going to be 221.1. 221.1 over 360 multiplied by pi multiplied by 80 squared. So actually, we need it near centimeter squared. So I'll just type this into a calculator. I'm going to get 12348. 12348.6 to one decimal place there. And on this side, I'm going to get 484.9. And I've also got the 8,000 by 2. So I'm going to have to add 16,000 plus 484.9 to my 12,000. Let me just type that into a calculator. So it's going to give me 28. I think I've rounded off too early here. Actually, I've rounded both of these up. Maybe I should have kept 2 decimals till the end. 28833. If I go back to 2 decimals here and here, I get 0.4. But if I keep the 9 and the 6, I get 0.5. So just be careful with rounding too early, which I've done on this question. So it's 28833 centimeters squared.